Okay, what we're working on today is section 7.1 vocab. There's actually two sets of cards we're going to look at because one set is stuff that you're supposed to know, and I want to make sure you have it written down so you do know all the names that go with the shapes. So first of all, you have to know what a polygon is. A polygon is a closed figure with no curves. So these are all examples of polygons. So a polygon cannot have curves, and it also can't have anything like an X where it's separated into two sections. That would be considered two polygons. So a polygon has a closed figure with straight lines and no curves. A triangle is just a polygon with three sides. So triangle has three sides. The quadrilateral, that's the specific name for any four-sided figure. Four-sided polygon. We'll learn a lot about different types of quadrilaterals, but right now, a general four-sided figure is a quadrilateral. A pentagon has five sides. Here's a picture of a pentagon. This is a pentagon that's perfect. So this is a five-sided pentagon. A hexagon has an X in it, and so does six. So hexagon has six sides. Heptagon has seven sides. A lot of times people get hex and hept confused, but remember hex has an X and so does six. Octagon is like an octopus. It has eight sides. It's a stop sign. A nonagon has nine sides. A decagon is like a decade, which is 10 years. So a decagon has 10 sides. And then the last one we have, a specific name, is a dodeca, which is 2 with a decade, so it's 12 sides. There's not a specific one for 11, but these are the ones you'll learn the most. If I have something with an 11 sides, it's called an 11-gon, 11-G-O-N. 15 sides is a 15-gon. So, okay, now with polygons, you have a couple types. The first type is a concave, and a concave polygon is a polygon that has a vertex that's been pushed in. So you see this vertex right here, it's been pushed in. It's like it's a cave and you can walk in it. So if you see any shape where there's an area that you can walk kind of inside, that is concave. And then the last one we have is a convex, and a convex is where all the angles kind of point out. All the angles are on the outside, and there's no place that you can walk in the shape. So for the first part of these notes, you have to know all the different types of polygons, and then know the difference between concave and convex. And now we're going to go to the notes from actual 7.1, those vocabulary words. Okay, the first vocabulary word you have from section 7.1 is diagonals. The diagonals are a segment in a polygon that connects two non-adjacent vertices, so it goes through. So from this one point, there's 1, 2, 3, 4 diagonals. So diagonals go across the figure. Polygon interior angle sum theorem. And so this tells you it's a formula that will give you the sum of the interior angles of any polygon. And that is n minus 2 times 180. So it's the number of sides minus 2 times 180. An equilateral polygon, well, you know equilateral from equilateral triangles. An equilateral just means that it has equal sides. So an equilateral polygon has all equal sides. So here's a, what is this, a pentagon with all equal sides. An equiangular polygon is, we know that word too, equiangular means equal angles. And so an equiangular polygon has all equal angles. So here is a hexagon with 6 equal angles. A regular polygon is something that's equilateral and equiangular. So it has equal sides and equal angles. If it's regular, it's perfect. Everything's the same. And so this is a regular hexagon versus this one, which was just an equiangular hexagon. So you see this one's kind of stretched out, while this one, everything's the same. Okay, the exterior angles of a polygon. If I walk around a shape, it doesn't matter what shape I walk around, I always walk around the shape and it's 360 degrees. So it could be a pentagon I walk outside and it's 360. It could be a square I walk outside, it's 360. All exterior angles always add up to 360. Interior angle of a regular polygon. So remember, a regular polygon means it's perfect, everything's the same. So a regular polygon, all the angles are equal. So what you do is you find the sum, which is n minus 2 times 180, but then you divide by the number of sides. And we'll do lots of examples so you can see what that is. And that's it. So remember your different vocabulary words. The big formula you have to remember is that n minus 2 times 180, but we'll do lots of examples with those.